Okay, perfect. Hi, everyone. Who is a staker here? Raise your hand. Okay, pretty much the whole room. That's great. So this talk is for you. This is the stake map, the Strawman roadmap for stakers. So what I'd like to do is start with this document that was published about a month ago. You can find it on strawmap.org. And what I've done is that I've taken the subset that is relevant for stakers, and we have a new domain, stakemap.org, that you can check out now. That is basically just this slide. Now, what I've done to help us walk through the stake map is color code the various boxes. So we have green boxes that are generally like good for stakers. We have red boxes that are kind of bad or apply pressure in some way that's worth discussing. And we also have in the black outline there some of the boxes that in bold where you need to pay special attention because there's like some sort of potential change to your setups, your DevOps, and the dashed lines is actually a good thing. It means that there's a potential simplification to your setup. Okay, so let's start from a clean slate and basically add the boxes one by one and walk you through the stake map. So I'm going to do this layer by layer, starting from the execution layer at the very bottom, the data layer, and then the consensus layer. And the way that this document is organized is that we have the various forks. So we have 7 forks covering 4 years, so roughly 2 forks per year. So our starting point at the execution layer is this idea that we're going to increase the gas limit a lot. And this is going to put pressure on stakers who have to process all of these blocks. And we actually have this proposal from Dankrat before he left where we can have the gas limit increase automatically. So there won't be any need to basically have to manually override your gas limit setting. And this is why it's a potential simplification to your setup in the dash lines. Okay, so that is our starting point. In order to deal with the increase in gas limit, we're going to have to deal with multiple resources. One is state growth. How do we make this manageable for stakers? And the best idea that we have here is called multidimensional pricing, where in addition to having a gas for execution and a gas for blobs, we would also have a gas for state growth, and we will have a corresponding gas limit. And that gas limit can be set in such a way that it is sustainable. We also have another idea called block in blobs. So what does that mean? It means that we take EVM blocks and we put them in blobs. And so instead of having to download the EVM blocks, you can just do data availability sampling, and this is a massive improvement on the bandwidth standpoint. Now, in order to enjoy block and blobs, you actually need to verify ZK EVM proofs. Because you're not downloading the blocks, you won't be able to naively re-execute them. So in HStar, we have this proposal called optional proofs, where early adopters like yourselves could opt in to download ZK EVM proofs instead of verifying the blocks naively. And that will be a massive change and simplification to your setup. You won't need an NVMe hard drive. You won't need a powerful computer. You won't need necessarily a powerful internet connection, especially when the gas limit increases. Now, optional proof is kind of the training wheel mode. We don't recommend it to large stakers, such as institutional stakers, because we want to keep the amount of ETH staked that is on those training wheels relatively small. But then eventually we will have mandatory proofs. And at that point, all of the validators will be verifying ZK EVM proofs, and it will be an extremely lightweight thing to run staking nodes. But there is one small detail, which is that we still want the validators to be maintaining the mempool and to help with censorship resistance. So there's this idea called validity-only partial state, also known as VOPS. And it's basically asking the validators to keep a subset of the whole state that is relevant for maintaining the mempool. So when you have a transaction on the mempool, you want to know that it pays for gas. This is the main anti-Sybil mechanism. And in order to know that it pays for gas, you need to know the account balance, and you need to know the nonce, and like just a small amount of data. and it's roughly 10% of the whole state. So today's Ethereum state, call it roughly speaking 100 gigabytes. You only have to store 10 gigabytes if you want to participate in maintaining the mempool and with censorship resistance. Now, related to VOPs is this other upgrade called binary trees. So the idea here is to move from a hexarray tree to a binary tree. And the reason why I put it in red with a bold outline is because in the transition point from hexarray trees to binary trees, one of the proposals is to run both trees in parallel. And so what that means is that you have to store kind of an extra copy of the state, and that might be an extra 100 gigabytes or whatever overhead, and that might require some sort of intervention from the staking operators, but hopefully not too much of a big deal. And then we also have BALS, which is coming in the next fork in Amsterdam. And here, it's generally a good thing, because it means that verifying blocks should be much easier. You won't need a fancy NVMe hard drive because you'll be prefetching all of the state that you're accessing. We'll be able to increase the gas limit more safely. But there's a little bit of a red outline because there is going to be a little bit of an increase in bandwidth usage, at least before we have things like zkVM proofs. Okay, and then final box at the execution layer is what is nebulously called endgame state. And the idea here is to try and find some sort of solution that's sustainable in the long term for state growth. And one of the ideas is called state expiry, which is basically saying that if you have some pieces of state that are unused, so you have some accounts or some smart contracts that no one touches for an extended period of time, you can just prune them away from the state. And if for whatever reason the owner of that state wants to revive it, or anyone wants to revive it, they can pay the gas cost to revive it in a safe way. And so that would mean that the VOPs state would also benefit from this pruning and make things more sustainable for the validators. Okay. Next up, we have the data layer. So the main pressure point at the data layer is that we want to increase the number of blobs on a regular basis. So what we have in the Strawmap right now is a blob increase through so-called BPOs, blobs parameters only every year. So that would be once every couple forks. And eventually, we have these very ambitious plans, to have 1 gigabyte per second of data availability that would unlock, so-called teragas L2s, where all of Ethereum could process, millions of transactions per second and be the center of the Internet of Value. Now, we already have data availability sampling, which is already fantastic to deal with the increase in blob count. But there's a couple other ideas. One idea is called blob streaming. So here, you download and process and sample the blobs ahead of time, off-chain, before they go on-chain. And so that means that you can spread the bandwidth load outside of the critical path, which is going to alleviate things here. And then there's another, quite exciting development. So ETH P2P is a new networking library that was open source just a couple days ago. It's developed by the Ethereum Foundation, Raul and the networking team. And basically, they're suggesting moving away from libp2p, which is quite inefficient, and having all sorts of clever ideas like erasure-coded broadcast in order to dramatically reduce the total bandwidth consumption of the peer-to-peer network. Okay, so that's the data layer. Notice that none of the boxes here are in bold, so there's really nothing to worry too much about from the point of view of a staker. Now, if we look at the consensus layer, this is where things are a little bit more subtle. So one source of pressure is in terms of continuously improving the slot duration. So we're at 12 seconds now. There's a proposal called quick slots, which might bring it down a little bit, potentially to 10 seconds or 8 seconds. Maybe it'll go down to 6 seconds, and then potentially even lower, 4 seconds, 3 seconds, 2 seconds. We don't really know, but more likely than not, it will go down quite significantly. And this increases the amount of bandwidth usage because there's a fixed overhead per block that needs to be dealt with somehow. And it also has some pressure on geographical collocation and things like latency. So that's something that will be partially mitigated by ETH P2P, for example. Now we have another source of pressure, which is this idea that we want the validators to be voting more often. So right now, as an attester, you vote once every epoch, and the epochs are quite long. It's 6.4 minutes. So there's a proposal here called 4-slot rounds. So that's a round of voting, and that would dramatically reduce the epoch duration effectively, and mean that you'll have to do more work. And both of these upgrades here, like reducing the slot duration and reducing the voting rounds, are to a large extent unlocked by this idea called decoupled consensus. So right now, we're coupling the so-called heartbeat with the finality gadget. So everyone's familiar with the finality gadget, but what is the heartbeat? The heartbeat is basically the mechanism that keeps chain growth. So what is the mechanism that keeps the chain from growing and gives us liveness? So Ethereum has had liveness, 100% uptime for the last 10 years. And the idea here is to change the liveness mechanism to have a randomly sampled committee of 256 validators, again, randomly sampled at every single slot. And that would be a different mechanism to the fast finality. And so this modularity gives us the opportunity to update things on different schedules. Now, in order to dramatically reduce the voting duration, we will need to try and encourage the validators to consolidate. So we have this proposal, and it's bolded. This is something that you have to pay attention to. This proposal to cap the number of attesters to 128K. So what does that mean? It means that the attesters will be ordered by balance, so greatest balance to the smallest balance. And if you're not in the top 128K, you get forcefully exited. So basically, as an operator, there's a couple things that you can do. Either you can consolidate if you have multiple validators. That would be the preferable thing. And if you only happen to have one single validator, like my suggestion would be just to make a little top up so that you're slightly above 32 ETH. You're maybe at 33 ETH. And 128 attesters is way more than validator slots that we need, because we only have about 8,000 actual operators. So hopefully there aren't that many attesters that are kicked out. Going back to this slide here, by reducing the total number of attesters by a factor of 8, it makes it easier to reduce by a factor of 8 the epoch duration. And then there's this final piece of pressure that comes from eventually what is a bit nebulous endgame finality, reducing the voting duration to the maximum, which might be 2 slots per round, or 1 slot per round, or 3 slots per round. We don't really know. Okay, now one of the things that the decoupled consensus gives us is this idea of having a post-quantum heartbeat that would come very, very soon, potentially in 2027. And the idea here is that if quantum computers were to come much earlier than we expect, we would have the opportunity to gracefully degrade Ethereum. So we would still have the chain liveness, the heartbeat, but we would disable the economic security. So we disable slashing because the slashing requires very fancy post-quantum cryptography with the aggregation, whereas the heartbeat doesn't need aggregation. And the reason is that there's only 256 attesters. The signatures are about 2 kilobytes each. And so we're talking about something like half a megabyte or maybe a megabyte of data, which is totally manageable. Now, another piece of action that needs to be taken by the validators is to register their post-quantum pub key. So this is a bit of an expensive action. It means that you have to go to your cold storage, access your withdrawal credentials, and sign a message saying, hey, my new post-quantum pub key is going to be XYZ, so that you can participate in the heartbeat. But the good news is that there's synergies with the attester cap and the consolidation. And the reason is that consolidating validators also requires touching your cold storage and your withdrawal credentials. And so you might as well do both things at the same time while you're at it. And if you so happen to control multiple validators, well, the tooling can just set the same pub key for all post-quantum pub key for all your validators, and also automatically do the consolidation. Now, another kind of consideration here which adds pressure is the idea that attestations are much more expensive in the post-quantum world. So BLS signatures are under 100 bytes, roughly 96 bytes, and they're going to grow dramatically, maybe a factor of 20x, all the way up to 2 kilobytes per attestation. And so that is going to put load on the peer-to-peer networking. But there is like some amount of good news here, which is that in the L-star fork, which is currently slated to be the big lean fork where we have the post-quantum upgrade, we have endgame finality, we also have an amount of cleanups that do provide a little bit of relief. So one of the advantages here for the stakers is that we're going to have very optimized queues. So right now, the deposit and the exit queues are just needlessly slow, and this is something that will provide a little bit of quality of life for the validators. We also have ePBS, which is coming very soon in Amsterdam. This is mostly a good thing for the validators. It gives them the option, if they want to not connect to relays, if they don't like relays. But there's a little bit of a red outline because there's potentially a new vector for denial of service attacks or things like that. So I'd like to see how it all pans out in production. And then we have Fossil here, which is marked in a bold outline. And the reason it's in bold is because some validators might want to opt out. So by default, the clients should be having the validators participate in censorship resistance through inclusion lists. But if you, for whatever reason, you don't want to participate, then you will have to explicitly opt out. And this is an action that you will have to make as a staker. And then we come to a couple boxes that are like much more speculative because they're a little bit controversial and are basically related to Jérôme's talk just before me. So the attester stake cap here, is something that is, in my opinion, extremely healthy for the entire network. I mostly agree with Jérôme's talk, but it does, very much change the economics for the stakers. So instead of having a minimum guaranteed like 2% yield for the stakers, we would have a market set yield, and the way this would work, of course, is by changing the issuance curve so that as soon as the total amount of ETH staked gets close to the cap, the yield starts going down. And the reason why I put it in bold here is because I expect some of the validators not to change their DevOps setup, but basically to start lobbying the social layer. And this is something that we've already seen. So I guess we're in France. There's a lot of strikes, and so maybe at next EthCC, all the stakers could kind of say, okay, we're going to shut down staking for one day or something in protest of the attester stake cap. Now, if we are going to do the stake cap, we should also do something called APS. And the reason is that if we do stake cap but not APS, then we would be in a position where the issuance, more likely than not, would be extremely low, potentially even zero. And all of the rewards would come, or most of the rewards would come from MEV. And MEV is extremely spiky. It's extremely noisy, and this would basically be a centralization vector, because the average validator would make much more than the median validator, and most of us are median validators, so we would be making much less money than the average validator, and it would basically be gambling. It would be a lottery, and it would be a centralization vector because it would incentivize pooling and smoothing. Okay, now there's a few final green boxes here. One, in the longer term, is the idea of having way more attestations per slot. So what I expect will happen is that when we consolidate the validators here with the capping, the minimum balance to become a validator will only increase a little bit, maybe from 32 ETH to 33 ETH, for example. And then when we go back and increase the number of attester slots, we would more likely than not just saturate the market with supply of attester slots, and there wouldn't be enough demand, right? There isn't a million operators out there who want to be staking. And so the minimum deposit to become a validator will be much closer to whatever we set it to, which could be some arbitrary number like 1 ETH. And so this is kind of an action call for those who don't have 32 ETH, but might want to stake in the future. You probably will be able to then. We also have a box here called secret proposers. This is kind of a quality of life thing where, as a proposer, you don't leak your IP address ahead of time, and so you're not exposed to denial of service attacks. And then there's another quality of life thing called real-time consensus layer proof. So the idea here is that instead of having to verify blocks the naive way, you can just verify proofs, which is much cheaper. So for example, if you're syncing from the chain because you went offline for a little bit, that will be much faster. And it also opens up the possibility, if you want to stake on a ridiculously low-powered device like a Raspberry Pi or even a $10 Raspberry Pi Pico. So that's pretty much it, and happy to take questions. Thank you.
Just a question on the post-quantum cryptography here. It seems to be the big theme of this conference. In your roadmap that you indicated here, what roadblocks do you see that would prevent us from becoming post-quantum proof? And what are solved and what are not solved? And is your deadline going to make the merging Q day that's coming closer and closer?
Yeah, so a lot of progress is being made of quantum computers, but very few experts believe that we're going to have cryptographically relevant quantum computers, also known as CROCs, before 2030. And the idea here is to try and complete the entirety of the post-quantum migration by 2029. We do have a lot of work because we have to migrate the consensus layer, the data layer, and the execution layer, each of which is using 3 different pieces of cryptography. Specifically BLS for the consensus layer, KZG for the data layer, and ECDSA for the execution layer. Now, we have been working for quite a while now on the solution to post-quantum. We have a new team, the post-quantum team with Emile and Thomas. And at first approximation, I'd say we have done all of the research, we've done a lot of the prototyping, and now it's a matter of productionizing. So we have 10 different client teams that are, have implemented these post-quantum clients in the context of lean consensus. We have had 4 devnets. We have the equivalent of BLST. So this is the library for BLS in a post-quantum flavor, which is called Lean VM. We've done a lot of the hardcore cryptographic R&D, with the consensus team. We've optimized these hash-based signatures. So at this point, I'm feeling extremely good about the Ethereum's roadmap. What I think will happen is that the whole blockchain industry will copy Ethereum, because right now, almost no one is tackling the hard problem, which is so-called signature aggregation. So I already mentioned the size problem, that an individual's post-quantum signature is at least 10 times larger than ECDSA. And the only solution that I know of is to use snarks to aggregate all of those signatures. And no one's working on this other than the Ethereum Foundation. And one of the strategies that we're taking is to, ironically, partner with Bitcoiners. And the reason here is that if we can pill the Bitcoiners in using the same solution that we have, then we basically will create a de facto standard, because the top 2 blockchains will have adopted it, and it's an easy copy-paste for everyone else. And turns out that Blockstream is now taking this seriously. We had conversations with them, and we have a solution which is extremely Bitcoin friendly, where they only need a single hash function, and they can use SHA-2, which they already have, so for them it's a sunk cost. And ironically, it also provides a scalability increase for them. And the reason is that in any given Bitcoin block, there's roughly 10,000 signatures. Each signature is 64 bytes ECDSA, so that's 640 kilobytes of data. But the proofs that we're developing are about 100 kilobytes. So it's basically a 6x improvement in data overhead for the signatures, which would allow Bitcoin to adopt post-quantum signatures without decreasing their throughput, and also without increasing the block size, which is socially very difficult for them to do. Okay, we're out of time. Thank you.
We have time for questions.